Fire in the hole. Welcome back, everybody, to Fro-Dog Arcade Repair. We have Sanwa number 5 on the bench. Sanwa, Sanwa, Sanwa broke and Fro-Dog fix it. San, me say San, me say San, me say Sanwa. All right, channeled a little inner Harry Belafonte. Let's do our visual inspection. From the top side, I see partial recaps. Those 3 may or may not have been replaced. That one's glued, so it's still original. Down in here, there's at least one over here. Let's do a couple spot checks to see if they are the right value based on the last one we dealt with. All right. Let's get our cap kit list out from previous work. Let's look here. C111, C111, 47 at 250, 47 at 200. A little underrated. All right. We got over here in position C312 is 470 at 50. C312, 470 at 50. That one hadn't been touched. This one has C310. 310 is 220 at 50, or supposed to be. What do we have in the hole? 220 at 35. Just slightly underrated. So, not real happy with the partial cap kit, but we'll deal with that. We'll end up doing a full cap kit, getting rid of the wrong value partials. Nothing looks burnt, crusty, broken, cracked so far. Flyback has been replaced. That is an aftermarket flyback. Solder job on it don't look too bad. Good news, our board is not cracked. Last couple we've had a cracked board. Biggest thing I see is our sand block resistor down here is a dingly dangling and a wobbling around. And what we have on the back side is a trace completely broken off and a solder joint that's done for. All right, let's just pull that off the board here. Oh, there's the pad. Wipe it off on our sponge. How's the other pad? It seems to be attached. Let's find a little wick here. Clean it up. That resistor seems to be a weak spot. I think it has to do with just flat out, how it's shipped or whatnot. This pad is attached, perhaps not the best. And we'll have to see. Let's take a look at why that broke from the board. Oh, the tines on that are pretty well bent, the ones that keep it level on the board. Let's straighten that up a little bit. Legs themselves don't look too bad. Okay. All right, that looks like it can go back in. Let's look. Anything else look crispy or wrong? We got some globby solder, but no shorts or no glom overs. Our Q403 has been reflowed. We've found that to be a weak point. Maybe not reflowed the best, but reflowed. some of the header pins. That's a cap over in the flyback cage. Interesting how 4 of them look reflowed. Oh, that one is absolutely ringed. This pin right here has broken connection. Somebody reflowed the wafer ICs there. We got some reflow work here on this header. Quite frankly, the only thing I see wrong is that busted resistor and some solder work that needs chased after a little bit. While I am thinking about it or looking at it, let's reflow this set of pins right here where we absolutely have a visible cracked ringed joint. Alright. See anything else that looks sketchy or so-so? These can look a little sketchy, and I do like to put some solder on them, but they're rivet through the board, so that rivet is what makes them look a little sketchier than they are. Reflow the other side of that transformer or choke. Transformer, since it's labeled T403. These look like they could stand a little bit of love. Over at T802. A couple of the pins have seen some quote-unquote love, just maybe semi-loving. Monkey husbandry. I don't think we've got monkey husbandry going on this one. Simian fornication, but I do see D302. I want to take a look at it. The top side looks like the solder joints are not connected well. Is the component loose? No, it does not appear to be loose from the board. But the joint itself, let's see if I can get this up here where we can see it a little better. The joint itself, we're not going to be able to focus on that, are we? No. You're going to have to take my word for it on that one, that the solder joint looks bagel-like. That's the best way to describe it, is bagel-like. That usually comes from a reflow where the pin of the component has seen some heat, has a little oxidation or corrosion on it. When they add new solder, it doesn't wet to the pin, only to the pad. So I'm going to take our fiberglass brush here, scrub at that just a little bit. Let's see if we can get some solder to wet to it better and not have us a bagel. Now, I like everything bagels, I just don't like solder bagels. Yeah, that looks better. I think we'll do the same thing to the other pin, and that D302 should be good. Get rid of our, wick off our extra solder. There we go. A little scrubby scrub with the fiberglass pen. And a little fresh solder. Oh yeah, much better. Fro-Dog like. Yeah, I would say the worst thing I see is reflows a little globby and sketchy, but Our real failure is this broken resistor down here. R803 is that sand block. Let's take a look at our neck board. Now, I will say, I have this habit of as soon as I grab something, I like to straighten the components if they're all boogered up, bent over, looking weird. So I already did a little component straightening on this, especially those 3 resistors to our 3 color channels. Nothing looks burnt. No loose wires. There are a couple of things that could stand some touch-up reflow, but nothing serious. I think that looks acceptable. I say we take our meter, we'll check our power supply. Well, let's check our fuses first. If we've got a fuse problem, then we know we've got deeper issues. All right. Let's check them out of circuit just to make sure. Let's lift one side of them up. Yeah, I see the fuse holders look all kind of corroded again on this one, blackened. So we'll probably replace those. Let's see, continuity and fuse checks good. Is it the right value? That's become a thing that I need to start looking for more and more. 4 amp. It is the right value. It's a 5mm by 20mm fuse. Ceramic. What is this one? Labeled 1.6. That's correct. And fuse is good. Let's put it back in the holders. Let's check our HOT. Let's get over on diode here. There's nothing shorted to the case, is it? Because it's flybacks in circuit, we can absolutely get a false reading there. I don't believe it is shorted. Alright, got a couple junctions there on Q406 over in the vertical circuit. Let's go to ohms. 3.9 and 4.0. Those are good. Our 2 resistors in with the flyback. So the flyback has been replaced. That's absolutely an aftermarket flyback, though it's not brand new to supercurrent time. It's just brand new in general. It's not an original. It's an aftermarket replacement. Let's check our transistor over here in the power supply. Got our 2 junctions. Nothing is shorted to ground, which I wouldn't expect with fuses good, unless somebody just put the fuse in. I see no burnt components. Overall, there's not discoloration much going on. I don't think the chassis is a very high hour unit. By gosh, I think this thing should work if we fix that pad for that sand block resistor down here at R803 and get it reinstalled. I think we're going to take it over, put it on a tube, and light it up. Then we can always come back and cap kits and then go back to the tube for adjustments and burn-in. Must be living right. Number 4 needed a bunch of work, both structural and electronic. And number 5 here just damn near looks like it's ready to plug in and light up. Again, not jumping for joy that we've got some capacitance under spec on the couple of caps I saw, but at least they're the right value. Let's find a component leg in our component leg cup. See if there's one I like the looks of. Let's see about this one. Let's make a little curly Q on the end. That'll go around our leg nice. Okay. I think we got a leg made. Now let's scrape some insulation off, or some green lacquer, I should say, off this trace. Expose the copper. Get some solder to wet to it. Yeah, I thought maybe that would sand through a little quicker, I think, where it scraped. All right, now let's sand a little bit to polish it up and expose it. That component looks, it's making connection, but it is a little bagel-like there next to it. We'll get that when we do a cap kit and general reflow. I think there's about 3 feet of solder wick in this thing's future to clear up some sketchy reflow and kind of do it up the Fro-Dog way. All right, get that wetted. That could go all the way over to that other pin. I don't think it needs to. Let's cut it off. I think my cheap cuts are getting a little dull at the tip. And the wire goes flying. All right. Get that to lay on there just like I like. All right, I like that part of the connection. Now, we solder over here around this loop. We ought to get a pretty decent mechanical connection to the board. We can't pull the solder back through the hole. Yeah. Now, solder its sister leg up better here. Yeah. I don't like it. We'll take some solder off, try again. You don't get too many tries with the solder before there's not enough flux left in it to wet good to anything. Let's take care of that donut that we're looking at. The rectifier here has donuts too. Got a 4-pin bridge. Nothing overwhelming, just a lot of globby solder on it. Okay. Our fiberglass pin. Kind of shine up those component legs a little bit so they wet a little better. I don't need an air compressor, I just blow on it. All right, D801, our bridge rectifier looks a lot nicer there. Let's get this leg of R803. Okay, I could sit here and do the whole reflow on camera, but I don't think that's necessary. I'm gonna put it back in its frame, slide it on a tube, and I don't know, I got a real good feeling this one's gonna light off. All right, welcome back. We're over here with Sanwa number 5. I've got it on a tube. If you notice, the color of the high voltage cup is black, shiny, looks pretty new. That's another indicator to me that it's a replacement flyback. The originals that I'm seeing on all, like this one next to it, are gray. So that's one indicator. But let's see that we got everything hooked up. We've got our neck board on. We've got our ground tag down there to the neck board. We've got signal on the board here. Got a remote board plugged in. Got our yoke on the normal. We've got our power wires over around and back in here. So we have our AC hooked up. We have our D-gals hooked up. And of course, we've got our high voltage anode hooked up. Over here, we've got signal coming in from our old school BK NTSC generator. There's our remote board ready to go. Power over to the fire in the hole switch. So, without further ado, fire in the hole. Oh, I heard it come up. Let's see what we've got for a picture here in the mirror, if anything. Yeah. It's a little dim. It's got some pincushion going on. But we are up. That's good. Let's turn our brightness all the way down. Let's bring our screen up just till we get retrace and just back down off a little bit. Bring our brightness back up. There we go. Now, I think we've got some pincushion adjustment over on this side. Yeah, it doesn't like that real well. Vertical size works. Shrink it down just a little bit. Vertical hold works. Vertical position works. Horizontal position works. Horizontal hold. We don't really get a rolling, but we can hear a change in frequency and a little bit of shift. Horizontal size. Horizontal size does not work. Brightness does. Colors do. All right. Horizontal size does not change. And we've got a pincushion problem. All right, we're back working with Sanwa number 5. This is the one we have no pincushion adjustment, horizontal size. Those controls aren't working. So I've really sat down with the print and gone through, looking through, is power getting everywhere it needs to go? I specifically went to over in the horizontal section looking for a smoking gun, if you will. Either a completely bad shorted cap, something. I found a couple of questionable caps, but not terrible. And then as I was touching up solder joints and doing some reflow, I decided to go ahead and do the cap kit. So I started putting the caps in, taking the old caps out, putting new ones in, and I saw a couple joints. I'm like, as somebody else's, hit these with an iron. I got a little bulbous extra solder on them. And I had already taken a meter and taken a look at this coil and this resistor as part of the circuit. And as soon as I touched the iron to this pin on our, 435, which is a sand block resistor sitting up vertical, the moment I touched the iron to it, pad came right off, stuck to the end of the iron and came right up with the solder. So I wonder if I had a broken or sketchy connection there. I haven't looked back at the print to see what R435 feeds, if that would be the only failures I would experience. For being such a heavy sand block resistor, our white one sitting right back in here, I would expect it to be feeding more, but that having the pad just lift right out with the touch of the iron really makes me think, suspect what's going on there. Now, as you can see, I already started scraping the pad next to it to get it cleaned up, ready to wrap a wire around, take an old component lead and make good connection to the next pad, and then I'll cover that with the green conformal coating that cures with a UV light, tidy that up. Kind of like I did down here where this pad was busted on that sand block that's on the other side. What I ultimately found on the pincushion problem, I initially thought it was related to this pad right here. And though that pad was open and separated. If I truly had a bad connection that wasn't making anywhere on this pad, I'd have had other problems as well. What it ultimately turned out to be was here at Q406, I had bad solder connections here on this transistor. On forums and other places, you will find possibility of folks telling you that Q406 here, next to our vertical IC, that this is bad or can be bad as to cause you no pincushion function for your controls. It may very well go bad as well. My problem was indeed connection related. I removed all the old solder, I removed the transistor itself, checked it out of circuit, and I cleaned up the pads and resoldered it, put it back in place, put some fresh heatsink compound behind it, and we cured up our pincushion with that repair. So pincushion problems are related to Q406, whether that transistor is always bad and replacing it solves things, or whether it is connection related and by replacing it, folks have found resolution because soldering in a new one makes good connections. But I would check for connection problems first if you were looking at a Sanwa PM1745 for pincushion problems. Okay, back with Sanwa number 5 again. There was something bothering me. I was looking at the transistor and the power supply, and it had that same round, like a sleeve that the transistor went up into for heatsink and insulation. And it looked exactly like the same aftermarket heatsink configuration on the one that had the wrong power transistor in it from another Sanwa chassis in this series. So I went ahead and pulled it, and sure enough it is. It is another Sanken C4138. Now, it's been in there long enough that the heatsink sleeve that it was in, the blue silicone, was brittle. It started tearing fairly easy trying to get it out, and it was cooked to the heatsink pretty good. This was obviously functioning, but my problem I have is that specification-wise, it is underrated compared to the correct C3831. Is it a substitute that will work and function? Yes. How long will it function? I don't know. Maybe the circuit is perfectly fine with the lower spec 4138 for long-term reliability, but the manufacturer spec'd a 3831. That's what have been in the others that have not been replaced or had power supply section repaired. So we're going to swap that underpowered transistor out for the correct spec C3831. Again, I don't think this has anything to do with our pincushion issues. It's just something I spotted that wasn't right. So just wanted that quick wrap up, and we are finished with Sanwa number 5. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends, and remember, fire in the hole.